Okay, ladies and gentlemen, this is Mr. Green. This is another of my lessons on Unit 1 in Algebra 1, and we're looking at equations today. Now, I know we've already told you what an equation is, but I want to make certain I express it real clearly. An equation is something that has an equal sign. If it has an equal sign, it's an equation. Right there. Now, the question really is with equations, how do you solve them? Well, there's two basic techniques. Technique one that I want to talk to you about is called the guess and check technique. This technique is simply going to guess a number and then check if it's right. So if I guess that x was equal to 2, I would stick a 2 in there. I'd say 3 times 2, which is 6, minus 6, which is 0. I got 0 when I checked that when x was equal to 2. Is 0 the same as the 15 that they told me in the problem? No. So my guess was obviously not correct, and I need to change my guess. In this case, it needs to be bigger than 2. So I'm going to guess another number, something bigger than 2. So if I guess in this situation where x was equal to 5, so I'm going to say 3 times 5, that's 15, minus 6, that gives me a 9. 9 and 15 are not the same. So it's still got to be bigger than 5. So my next guess is going to be 7. I'm guessing x is equal to 7. So 3 times 7 is 21, minus 6 is 15. Hey, I got it. 15 is equal to 15. X must be a 7. Okay? Now this technique works well if it's an easy problem. Okay? And it might be a technique that you used in earlier grades. But this technique does have problems when you start getting into some harder equations that you're trying to solve. And it makes it, you might be guessing quite a few answers before you get there. And if the answers are decimal at all, you might have hundreds of things that you could try. And it gets very difficult to do. Okay? So what we want to do is we want to try a different approach. This approach is called the balance approach. And what we're going to do is we're going to try to balance as if it were um, on a seesaw. That's what I'll think about. So if you've got a seesaw sitting here and you've got a balance point here, you know that if you put two or three people over here, you got to put the same weight over here to get it to balance out. Now you might put a person over here and it goes down, and then this one goes up. And then you want to put some more weight over here so that this one comes down and this one goes up, and it goes back and forth. Well, what our ideal situation would be is that we remain consistently balanced. Our equation is balanced to begin with, 3x minus 6 and 15. It's balanced around that equal sign right there, right? So we want to try to keep it balanced. And what we would do is we'd look at both the sides of this equation. We say, look, I'm subtracting 6 over here. What if I added 6 to this side of the equation? Well, I need to add 6 to this side over here so that they remain balanced. But plus 6 minus 6 winds up being 0. So those cancel each other out. And I wind up with a 21 on this other side over here. And I've got 3x is equal to 21. Well, 3x we know is multiplying 3 times x. So if I divided by 3, which is the opposite operation there, 3 divided by 3 is 1, and I'll wind up with an x on this side. And I take 21 divided by 3 on this other side because I had to do that same dividing by 3, and I'll wind up with a 7. So I now have x and 7, and it's a balanced equation. And now we can always check it and stick that 7 back in. 3 times 7 is 21, minus 6 is 15. So it is possible to do that. But this technique of keeping the balance, or doing the opposite operation every time, helps us solve equations. Let's try a couple here, just see what's going on. This one says v minus 10 equals negative 9. There's the point I want to try to balance right there, the equal sign. So I'm looking at this and I want to solve for v, so I'm going to circle v right there. And since it has a minus 10, I think what I would do would be to add 10 to both sides of the equation. So when I add 10 and minus 10, that becomes a 0. So I'll wind up with v on this side. And then on this side, I've got minus 9 plus 10. That's going to be equal to 1. V is equal to 1. Oh, that worked pretty well. Let's try that again. Let's draw a line through the equal sign. Look at our equation over here. We got v over here, and I got a minus 10, so that means I'm going to add 10 to both sides of the equation. And when I add 10 to this side, I'm going to get a v, because that's going to be v plus 0, v. And then minus 3 plus 10, that's going to be a 7. In this situation, v is equal to 7. Cool. Let's try a few more here. Here I've got x minus 3 is equal to 4. I'm going to draw a line there. X is what I'm going to be solving for, so I'm going to circle my x there. That means I need to add 4 to both sides of my equation. 3. Excuse me. Add 3 to both sides of my equation. Why am I adding 3? Because it's being subtracted in the original equation. I want to get rid of that 3. And I'll be getting an x is equal to 7. Let's come over here to number 4. Draw my line like I did before. Circle my x. That's what I'm solving for. X is being divided by 5. The opposite of dividing is multiplying. So if I multiply by 5 on both sides of this equation, what I'll get is 5x divided by 5, or 5 divided by 5 is 1. So I'm going to wind up with x over here. And 2 times 5 is 10. X is equal to 10. Okay? Looking at number 5 down here, drawing my line through my equal sign. I've got my variables over here this time. Does that make a difference? Not really. I've got negative 11k, so it's being multiplied, so I'm going to divide by negative 11. Negative 11 divided by negative 11 becomes 1, so I'll wind up with k on this side. I'm going to divide this side by negative 11. 22 divided by negative 11 is a negative 2. I've got a positive divided by a negative. So k is equal to a negative 2. Okay? Same thing over here. Draw a line. It's being multiplied by negative 13. I'm going to divide by negative 13. So I'm going to divide by negative 13. This becomes m equals. And over here I've got negative divided by negative. That becomes a positive. And I've got 377 divided by 13. I can't do that one in my head. Let's see here. 3 times 3 is 39. Can't do 3, so it's going to be 2. 26. That's going to give me 117. Let's see here. Let's see. 13 times 7 is 21. Carry your 2. 70. 91. It's not going to be 7. 13 times 8 is 4. Carry your 2. 8. 104. I don't think I can go any higher than that. So 28. That's 104. And I subtract and I get a 13. Oh, I could have gone one higher, couldn't I? 9. 29 would be 113 or 117. And it would subtract, give me 0. So my answer there is 29. You know, this points out a good thing. Can you use a calculator in algebra? You know, you need to know how to work these math correctly mathematically without the calculator, but there is a calculator in the materials at the very beginning of the course. If you can figure out how to get it working, it is the same type of calculator that you will have available to you when you do take the EOC test. A lot of times I'm going to try to do these lessons without calculators to show they can be done, but sometimes I will bring up a calculator and show you how it is done on a calculator so that you can use that calculator, because you want to make certain you're checking your work every time. And that is a good way of doing so. Okay, well, make certain you work all the problems offline that you need to work. Make certain you know how to do the work. Take the quiz. Keep current if you can, guys. And I look forward to seeing you in the next Class Connect or in tutoring or at the next lesson. Talk to you later. Bye.